Hello students, welcome to my class. Today I am taking class 9 mathematics and chapter number 8. Chapter name is Quadrilateral. So we have studied many properties of triangle in chapter 6, 7 and you know about triangles. And chapter 8 Quadrilateral. Quadrilateral is a figure, 10 figure bounded by 4 line segment. So some properties of quadrilaterals are there. One and foremost important property is angle sum property. Sum of the angles of a quadrilateral is 360 degree. Sum of the angles means 4 angles of a quadrilateral. So I am following NCERT book Mathematics class 9. You may join with me, open page number 160. So types of quadrilateral. There are 6 types of quadrilateral. First one is trapezium. The quadrilateral whose one pair of opposite sides are parallel is called trapezium. One pair of opposite sides. So this A, B, C, D. A, B and C, D parallel to each other. So this is a trapezium. Next, after trapezium there are parallelogram. The quadrilateral whose opposite sides are equal and parallel, then it is called parallelogram. This is a quadrilateral. Suppose AB, C, D. AB opposite to CD, AD opposite to BC. Opposite sides are equal and parallel. So it is a parallelogram. Next is rectangle. A parallelogram, same definition. A parallelogram having each angle is right angle, then it is called a rectangle. Here also opposite sides are equal and parallel. AB, CD. AB parallel to CD and AD parallel to BC. AB equal to CD and AD equal to BC. Opposite sides are equal and parallel, both having equal and parallel opposite sides, but in rectangle each angle is right angle. So the difference between parallelogram and rectangle is, in parallelogram opposite sides are equal and parallel, not mentioned about angle, but in rectangle opposite sides are equal and parallel and each angle is right angle. Next, square. Square. The rectangle whose all the sides are equal, then it is called a square. Here see, AB, BC, CD and DA, all the sides are equal and each angle is right angle, then it is a square. Now rhombus. Fifth one is 1, 2, 3, 4. Fifth one is rhombus. The quadrilateral whose each side is equal and opposite sides are parallel, then it is called rhombus. Okay. Fifth one is difference between, here similarity and difference between rhombus and square. If it is a square, it is also a rhombus. But if it is a rhombus, but it is not a square. You see, according to definition, all the sides are equal. Here all the sides are equal. Opposite sides are equal and parallel. Opposite sides are equal and parallel. So it is both are rhombus. But in rhombus, if all the angles are right angle, then it is only a square. So this is they are having some similarity, and this rectangle and parallelogram also having some similarity. Parallelogram and rhombus having some similarity. In all the parallelogram, all the rhombus are parallelogram, but all parallelograms are not rhombus. Here also all the sides are equal. Opposite sides are equal and parallel. Here also opposite sides are equal and parallel. So all the rhombus are parallelogram, but all rhombus are or parallelogram are not rhombus. In rhombus, all the sides must be equal. Fifth one is kite, which is like trapezium but not trapezium. Kite in book, page number 160, figure number 8.5, Roman 6. You see, ABCD is a kite, and here kite, definition of kite, you can say adjacent, two pair of adjacent sides are equal. A quadrilateral holds two pair of adjacent sides are equal. Here not of opposite sides. Here matter of adjacent side. AD and CD are equal. AB and BC are equal. A kite is not a parallelogram nor trapezium. It is simply another figure which has no relation with other five figure. Trapezium, parallelogram, rectangle, rhombus, square. With this five, with that five, there is no relation among kite and other five figures. Now some other properties. A square, you see page number 161. A square is a rectangle and not a rhombus. Look at the book, page number 161. A square is a rectangle and also a rhombus. A square is a rectangle and also a rhombus. I said it is a rhombus. This is a rhombus. It is a square, but it is also a rhombus. A kite is not a parallelogram. This is not a parallelogram. A parallelogram is a trapezium because a parallelogram and a trapezium having both the opposite sides are equal and parallel. So a rectangle or a rhombus is not a square. A rectangle having opposite sides are equal. That is, this is equal to this is equal to this. A rhombus, this one. Both are not square. According to definition, square having all the sides equal and each angle is right angle. Here also each angle is right angle, but opposite sides are equal. So a rectangle and a rhombus, not a square. But a square is also a rectangle. Okay. Now some properties of a parallelogram. Now we are solving some theoretical problem, that is theorem 8.1. A diagonal of a parallelogram divides it into two congruent triangles. We are going to prove this theorem. So, to prove a theorem, first of all, we have to know that what are the hints given in the statement and what is to prove. Then, if anything construction required, then to prove. That is, there are 4 parts. One is what is given. Number 2 is what is to prove. Number 3 is if construction if necessary, and number 4 is proof. Now we are starting to prove the theorem 8.1, page number 162. The diagonal of a parallelogram divides into two congruent triangles. So, first of all, we have given a parallelogram. Let ABCD be a parallelogram and AC be the diagonal. We have to prove that after drawing the diagonal, we got 2 triangles. We have to prove that these 2 triangles are congruent. Okay. So whatever we have drawn, we have to write it. Let ABCD be a parallelogram. AC be the diagonal which divides it into 2 triangles. So after getting 2 triangles, we have to prove that these 2 triangles are congruent. This is our theorem. To prove that, then what is to prove? To prove that 2 triangles, give the name triangle ABC and triangle ADC. Okay. Now to prove that triangle ABC is congruent to triangle ADC, we have to prove this. And to prove these 2 triangles are congruent, as we got in chapter 6 and 7, especially chapter 6, the congruence postulates. So we are using these postulates. For which postulates could be used? Let's see. So proof. In triangle ABC, comparing these 2 triangles and triangle ADC. Let us compare what we are getting. AB is equal to CD. AB is equal to CD. How? Because in question it is said, in theorem it is said that, and we have supposed also, we have declared also ABCD is a parallelogram, and in a parallelogram opposite sides are equal. So AB is equal to CD. Next, BC is equal to AD. BC is equal to AD. opposite sides of the parallelogram are equal. So, or you can say that given. Next, third one what? AC is common side. AC is common side. So we can say that by side, triple S postulate, triangle, A, B, C is congruent to triangle A, D, C. That was to prove. Hence, two triangles so formed are congruent. Proved. The first theorem is proved already. Next one is theorem 8.2. In a parallelogram, opposite sides are equal. So, elaborately we can say that opposite sides of a parallelogram are equal. Opposite sides of a parallelogram are equal. So, here also one parallelogram is required. So, keeping that diagram as it is. So, in a parallelogram, opposite sides are equal. So, it is declared that ABCD is a parallelogram and we have to prove that opposite sides are equal. Let ABCD, name is not given, so we are supposing name is ABCD. Let ABCD be a parallelogram. In short writing, parallelogram because of shortage of time, whose sides are AB, BC, CD and DA or AD. We have to prove that. What is to prove? Opposite sides are equal. So, AB is equal to CD and AD is equal to BC. AB is equal to CD and AD is equal to BC. So, construction. Whatever given we have written, what is to prove we have written. Now, construction if necessary, we need one construction. Here we have to draw at the diagonal, this part. The diagonal AC is drawn forming triangle ABC and triangle ADC. After drawing the diagonal, we got two triangles, triangle ABC and triangle ADC. If we can show the two triangles are congruent, then it will be easy to show the opposite sides are equal and opposite sides are equal. Proof. In triangle, so comparing these two triangles, in triangle ABC and triangle ADC. In triangle ABC and triangle ADC, we are comparing. You see, in earlier theorem, we have already written that AB is equal to CD, but we cannot write here because we have to prove this one that AB is equal to CD. So we will use other properties of theorem, parallelogram. So if we use this angle, these two angles, then these two angles, then we can prove this. Proof. ABC. In triangle ABC and triangle ADC, angle BAC is equal to angle BAC is equal to angle ACB. You see, given tick mark ACB. Look at the diagram in the board. BAC is equal to angle ACD. What is the reason behind it? Since AB parallel to CD, comma AC is transversal. So alternate angle formed are equal. Okay. And now this cross sign, you see, look at the cross signs. Again in parallelogram, AD parallel to BC, isn't it? So if AD parallel to BC, taking AC as transversal, we are getting two more alternate angles. So BCA, as because triangle ABC, so we will mention the name of the angle of this angle first. This triangle first. BCA is equal to angle DAC. Angle DAC. Here reason is since AD parallel to BC and AC is transversal. So alternate angles so formed are equal. Then third option. Third option is this common side. You see, AC is the side of triangle ABC as well as triangle ADC. So AC is the common side. So what we are getting? Which property? Which postulate? Angle, side angle. So therefore by angle, side angle postulate, triangle ABC is similar to triangle, congruent to triangle ADC. So after getting the triangle as congruent, we can say that AB is equal to CD, and therefore you can say that AB is equal to CD and AD is equal to BC. No. BC is equal to AD. That is AD is equal to BC. Hence, how these two lines CPCT correspondent part of congruent triangles are equal. So we can say that hence opposite sides are of a parallelogram are equal. So theorem 8.3 is over. Now we will probe theorem 8.3. We will try to solve 5 theorems at least. If not possible, then 4, and then we will discuss 2 or 3 questions from exercise 8.1. So let us now solve theorem 8.3. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. We have to prove this one. Look at the book, page number 163, theorem 8.3. I am not writing the question in the blackboard because it will be time consuming. So what is given here? Here also one quadrilateral is given, and opposite sides of quadrilateral we have to prove that equal to equal. ले जाओ. One quadrilateral we have to draw. ABCD is a, so if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. We have to prove. So we have to prove parallelogram. We will draw a parallelogram. We will draw a parallelogram, and but we will prove it is a parallelogram, and before that we are declaring it is a quadrilateral, because after all a parallelogram is a rectangle. Let ABCD be a quadrilateral. Let ABCD be a quadrilateral. Let ABCD be a quadrilateral. Okay. Let ABCD be a quadrilateral whose opposite sides are, which pair of opposite sides are equal? Whose opposite sides are AB, CD and AD BC. Opposite sides are equal. To prove that, A, B, C, D is a parallelogram. To prove that ABCD is a parallelogram. To prove, we need one construction. What is construction? The construction is same, just diagonal. If we draw the diagonal, then the quadrilateral become two parts. So the diagonal construction, the diagonal AC is drawn, forming triangle ABC and triangle ADC. Proof. Now we have to prove that this quadrilateral is a parallelogram by the using the property of parallelogram. So after getting the two triangles, now we are comparing these two triangles. So in triangle ABC and triangle ADC, in triangle ABC and triangle ADC, what we are getting? Opposite sides are equal, so we can say that these two sides are equal. AB is equal to CD and BC is equal to AD. BC is equal to AD. BC is equal to AD, and the third option is, because these two are given, third is AC is common side. AC is common side. So which postulate? Side, side, side. Therefore, by side, side, side postulate, we can say that triangle ABC is congruent to triangle ADC. Okay. So, but we have to prove that the quadrilateral is a parallelogram. So after getting the two congruent triangles, what we can say? We can say that these two angles are equal as CPCT. Therefore, angle BAC is equal to angle ACD because CPCT and angle, which one? This and this. Angle ACB, CPCT 1 and ACB is equal to angle CAD. Here also CPCT. Corresponding parts of congruent triangles are equal. So we have to prove that this quadrilateral is a parallelogram, and for that we showed these two triangles are congruent, and after showing these two triangles are congruent, we got two CPCTs, that is two opposite angles are two pair of angles are equal. Now using these two pairs of angles, we can say that triangle quadrilateral is a parallelogram. See how? Since angle BAC and angle ACD. You see BAC, the angle marked as tick mark BAC and angle ACD are alternate angle. You see alternate, no? This alternate, this alternate angles taking AC as transversal. And are equal. Therefore, we can say that just you give a look, these two sides are, there are two sides and one transversal is there. These two pair of alternate angles are equal. So we can say that these two lines are parallel. If one pair of alternate angles are equal, then we can say that the lines are parallel, sides are parallel. Therefore, we can say that AB parallel to CD. Similarly, short form of similarly, SILLY dot what? Angle ACB and angle CAD are pair of alternate angles and they are equal. Therefore, we can say that AD parallel to BC. Give this as number 1 and this as number 2. So, from this equation number 1 and 2, what are there? AB parallel to CD, AB parallel to CD and AD parallel to CD. AD parallel to BC. If two pair of opposite sides are equal, opposite sides are parallel, then you can say that this is a parallelogram. Therefore, A, B, C, D is a parallelogram. Proved. So, by this we have proved already theorem number 8.3. Now, if time permits, then we will solve theorem number 8.4 or now let us with this we will try to do page number 163 theorem 8.4. In a parallelogram, we have to prove that opposite angles are equal. Just we prove that opposite sides. In theorem number 8.2, we have proved that opposite sides are equal. Now we will prove that opposite angles are equal. In a parallelogram, opposite angles are equal. So, similar to this one, a bit difference will be there. So, before that, we have to draw a parallelogram. So, suppose this is a parallelogram, same parallelogram. So, let 8.4, let ABCD be a parallelogram whose opposite angles are angle angle ABC whose angles are angle ABC, angle BCD, angle BAD and angle BCD, CD, sorry, here it will be ADC and BAD. We have to prove that what is to prove that? We have to prove that opposite angles are equal, that is angle ABC is equal to angle ADC and angle BAD is equal to angle BCD. Let us prove this one. That is, we are going to prove in a parallelogram opposite angles are equal. So be with me, just follow the blackboard and try to understand. Now, one construction required. For this, AC, the diagonal AC is drawn forming triangle ABC and triangle ADC. We have to prove that angles are equal. Proof. Since AB parallel to CD, AC is transversal, therefore angle BAC is equal to angle ACD. Again, equation number 1. Again, AD parallel to BC and AC is transversal. Therefore, you can say that ACB is equal to angle what? ACB is equal to angle CAD. This is equation number 2. Now we have assets. Now we can prove that these two triangles are congruent. Now in triangle ABC and triangle ADC, from one angle BAC is equal to angle ACD and angle ACB is equal to angle CAD. Next, third option is This was from 1 and 2. 1 and 2. Third option is AC is common side. So we can say that by angle, side, angle, postulate triangle ABC is congruent to triangle ADC. All these four are likely similar, just some few differences are there. So we can say that postulates. So you see, this angle is equal to this angle, this angle is equal to this angle. You see, cross. So in triangle ABC, we have used two angles, so we can say that this third angle is also equal. So we can say that triangle ABC is equal to triangle ADC by simplicity. So similarly, we can show that angle, similarly considering diagonal BD, we can show that angle BAD is equal to angle BCD. Hence, opposite angles are equal. Proved. This is the proof of, this is the theorem of 8.4. As earlier I said, perhaps I can complete theorem 8.5, but due to shortage of time, I cannot proceed to 8.5. So let us start exercise 8.1. One or two sum, just I will give the hints. Exercise 8.1. Just follow the blackboard, look at the blackboard and follow my instruction. Page number 169. The angle of quadrilateral, look at the book. The angle of quadrilateral are in the ratio 3:5:9:13. Find the angles of the quadrilateral. Find all the angles of the quadrilateral. So there is a quadrilateral, suppose ABCD of any kind. A, B, C, D is a quadrilateral. Given ratios are 3:5:9:13. Let measure of angle A be 5x, measure of angle B equal to 5, C 9x, and measure of angle D is equal to 13x. Now, according to the angle sum property of the quadrilateral, sum of the four angles is 360 degree. Therefore, angle A plus angle B plus angle C plus angle D is equal to 360 degree. Implies, what is the measure of angle we have taken? 5x plus 5x plus 9x plus 13x is equal to 360 degree. So what is the sum of this? what so 30x is equal to 360 implies x is equal to 360 degree by 30 implies x is equal to 12 degree. So if the value of x is 12, then all the measure therefore the required measure of angle A is equal to 3 into 12 is equal to 36 degree. 5 into 12 is equal to 60 degree. 9 into 12 108 degree. And 13 into 12 is equal to 156 degree. So okay, so these are the measure of the angles of 4 angles of the given quadrilateral whose ratios are 3:5:9:13. So due to lack of time, I could not complete question number 2. Just I can give some hints that in question number 8 point exercise 8.1 question number 2. So if the diagonals of parallelogram are equal, then show that it is a rectangle. You will declare that ABCD is a rectangle, a parallelogram, but you will draw a rectangle. So in which AB is equal to CD and what AD is equal to BC. Also AB parallel to CD and AD parallel to BC. To prove that ABCD is a rectangle, like this, after there are 4 triangles you will get, because two diagonals A, B, C, D. Considering diagonal AC, you will get 2 triangles ABC and ADC. You will compare these 2 triangles and you will show how I have shown congruence of these 2 triangles. Then considering this diagonal BD, you will get 2 more triangles BAD and BCD. You will show that these 2 triangles are also congruent. Then you will proceed to the theorem that if the diagonals of a parallelogram are equal, then it is a rectangle. So if you found any doubt, if you face any problem, then you can text me or you can directly contact me about my phone numbers. And with this, I conclude my today's class. Thank you.